Right, recording on progress. Okay, how are you today?
I'm doing fine. How about you?
Good, good. I just can't. Sorry, been busy, for a week.
Hmm.
We skip
Understandable.
we kiss we kiss we skip many day, right? I'm sorry. No, I was in the business trip.
It's fine.
All right, so now let's come back here now. Let's what we have to from let's refresh quick, right? From the last lab that we already successful, we turn on the VPN side to side, and also we using the loopback as a tunnel, like underlay the IP address from the loopback crossing the VPN IP stack, right? And then we already prove it. We already have established the BGP between, okay, from the remote office. Then let's hop in quick here, quick. We just quick refresh in here. Let me see. Okay, we're in the Chicago here. Let me see here. Show IPBGP summary first, right? So okay, maybe the font a little bit bigger. Refresh it again here. Right, so now we have a two. Remember, this is MPLS, and also we have a 172. This is from the tunnel, right? When you show, let me see here. When you show IP interface brief, and then we should have a tunnel 10. You see, show run, show run internal interface tunnel 10, right? So this is the IP address. Oh, it's a shutdown. Hold on. Well, why we shut it down? Let me see. There we go. Hold on. Oh, maybe we try to test between the failover, right? Between the, I think last time we did it. Is that right? Or remember?
Mm.
Let me see here. Show IPBGP summary, right? So because maybe this is the last time that we tried to on purpose. See, we shut down the tunnel. That's why we lost the BGP pair now with the VPN IP stack, right? So now everything the routing from the Chicago, it should be routed into the MPLS, right? So now this is here. Show IPBGP again. See. So now all the traffic, you see, we're learning from the 152. Everything is from the MPLS, correct? So let's do a quick check in here then. So first thing, we go back to here again. So let's say we want to ping the 10.100.10, the VLAN 10, right? Dark 1 or dark 2, just dark 2. Yeah, you see? And also in here, we can trace now the 10.100.10.2. It should be crossing the MPLS. That is the reason from the last lab that we shut down uh, between two wending type. One is across the VPN side to side, and one is the MPLS, right? So now C10.205.10 go to this router, and then from this router, it should be go to the 152. Yes, you see, beautiful. And then it should be all the way go to here, that one. We should see that one. Oh, come on, hurry up. Yep, and then it should be all the way go to the 10.3 network, crossing the crossing this link here. And then, yep, beautiful. And then we should be hit at VLAN. Beautiful. So now, for example, now, so we go back to MPLS router again. So we're successful now. We ping. It's no problem ping from the remote office to the headquarter, right? So now, say, okay, we bring the tunnel back up in here, right? So the interface tunnel 10, and then we say no shutdown, right? So exit out. And then let's see the BGP form again. Beautiful. It's up already, you see? Right? So see, oh, it's still idle. Okay, hold on. Okay, so now it's up, you see? Active, okay, it's sending out. It's not complete yet. Okay, it's send hello. Now it's beautiful, you see? All right, so now we got the prefix, right? Now we show IPBGP again. We should be learn the headquarters. See the 10.100 10.10. It should be learned. We have a two path. right? One is from the MPLS, one is from the VPN side to side. But in this case, now once we bring the VPN side to side, the BGP go up again. Now it's preferred because we have a two hop in here. It's a shorter path. That's why the router from the MPLS say, hey, I received two route, and then one is from MPLS, one is from VPN, but I prefer go to VPN side to side because it's based from the how many hop, you see the path, right? So now let's do it. Now let's see again if we can ping again from here to prove it, right? So we go to ping 10 again. Beautiful. Now look, in this time, so what is the path now? You see, earlier we testing go to MPLS. Now we should be cross the VPN side to side. Okay, hurry up. Okay, and then same thing again. We should be hit this router. This is the gateway router. Yep. And then now we should be go to 172. Oh, yep, you see. And then we should go to 10.1000 network. Yep. And then we complete. You see, see from the MPLS, we have a 4 hop. Okay. So now you see from the VPN side to side, crossing the VPN side to side is only a 3 hop. So that is explained to you because the BGP is choose, who's the shorter path is the as a prefer. Okay, so now it's beautiful, right? So now we see we have a two winning, so we're not worried about. So from the last time they complained about, they opened the ticket issue, they complained about when we drop the MPLS and then everybody in this site is going to impact, right? So that's why we got complaint, and then that's fine, and then we order the another WAN type if in internet. Okay, so that be all. Okay, so now, so what we should do for today? Okay, so let's do something like this. Now let's open another scenario. Something like we open a ticket, right? Always have a ticket deal, right? In the production network, because like say right now we say from the site office here, we got the customer or agent or something, the coworker over there, the remote site coworker. They say been complained about why this network goes so slow. Okay, and then once we troubleshooting, right? When once we troubleshooting, and then somehow, like for example, like last night, but it's not said by accidentally. It's last night. Say something somehow from the desktop team, they like push the window update, and then say for example, if we have a small winding type, maybe we just only have a 10 megabit. Or maybe this is have a 100, so we don't know yet, right? We assume they have one is a lower have a lower something, lower speed, right? So that's why that is the reason now they complain about. So now, how about we know the problem is causing is from the window update, window patch update, right? Like window update when they update crossing the network, to the Microsoft, right? They have so many maybe here, maybe we have a 10 system or maybe a 20 system on the remote side. That's why when they push it, the script, like whatever the window update by GBO, Active Directory, they update from the GBO, they push it, they update the patch, the window update or something like the download from the Microsoft directly. And that's why causing the winding pipe here it's become like a bottleneck. So now they complain again. They come to us again. So now we are as a network engineer, right? So how we can make this solution now to optimize in this case. So first thing in here, let's do like this. First thing, we just pretend about like create in here. We create another loopback in here. So let's pretend this is Microsoft patch we're using the Microsoft, used to be, is a Microsoft like DNS server. We use this number. Everybody should be know for 4.4.4 or 4.4.2.2, something like that. That it should be like Microsoft. Okay. Let's just see show IP interface brief in here. You see. So now we just want to let's say we create another loopback in here. Interface loopback. Say we have 100. Say 101. Okay. IP address is we pretend this is a Microsoft, the window patch update IP address, the server. So 4.4.2.2, this is Microsoft. Okay, so now we have the user 255.255.255, just for example. Okay, so now we have more, now we need to advertise, say, Google and Microsoft. Let's rename this one. Okay, so not only so we have Google and also we have a Microsoft update server. It's 4.4.2.2 on this router. Okay, so we have a two in here. Let's bring it back again. So now exit out again here. Just make sure we show IP in the brief. And then we have a 4.4.4.2.2, right? So now same thing we need to advertise now, because this router have to be advertised to all to the Verizon or to the Comcast, right? Or advertise to the internet. All right. So now look at in here, show run section router BGP. Okay. So now we go to config T again. So we go to this BGP here, right? Hit enter. And then we're going to say network. We need to advertise 4.4.2.2. And then with the subnet mask should be 255.255.255, because it's a single one IP. Oh, typo. 255. Okay. So now save it first. All right. So let's try to ping now from here. Can we ping? First thing we ping 8.8.8 first. See can we ping Google? Beautiful. That we should able to ping Google. Now can we ping 4.4.4.2.2? Beautiful. You see? Yeah, in this case, right? So now because we have all the workstation connect to this Chicago switch workstation 1 here, right? So now let's say we want to know, for example, here, you see here, trace 4.4.2.2 in here. Where we go? How this go to the internet? All right. So this internet should be go to MPLS, right? It should be go to in MPLS, go to here, but it still go into the VPN site to site. See, should be all the way back to the headquarters. You see, go to the VPN site-to-site tunnel, and then go to 10.3 network. You see, and then it should be either go to Comcast or either go to the Verizon. It depends, right? What we left from the last lab, that maybe we still left over or not between the primary and the secondary. So now it's only to 1.6, yep, and then go to 173, beautiful. It's go to Verizon, you see, and then we can reach the 4.4.2.2. Okay, so now we understand the traffic flow now. So for everything from the Chicago, the computer, when they go to the window update, they going to the internet, right? But then you see the traffic path is all the way back to here, right? All the way back to here and then come back to here. All right. So that's why maybe this side, all right, or maybe we have a Maryland site, or maybe we have a headquarter, no, the remote colo site, or maybe we have a headquarter workstation here, because people suddenly say, why the internet so slow? Because they start complaining now. Okay, because they start complaining now. For example, from this side, when they go out to the internet, right, it's still going to this path, right, go to the primary Verizon, but then they complain for this side, they complain, say, why internet connectivity is so slow? When they go to the browsers, the browser is just like uh it's just when they reload the page, right, the internet page, and then the very low is very slow, the low to finish the low, the loading. Okay, so that's why now once we already identify the problem and we troubleshooting. Oh, okay, because somehow from the desktop team they pushed last night to the all the workstation in this side, and then they update the window update, because it's a big file. Until now they assume, because they push at night, they assume at night should be complete the task, but then it's not, because maybe they because we have a smalling something crossing the something, some issue, right? It's just causing very slow. All right, so that is mean right now during the production in the business hour. Okay, because like everybody's screaming why internet so slow, because now we already identified, discover the issue, the problem is causing from this workstation here. All right, so now, so from the engineer say, okay, since they have local internet, you see, since they have a local internet, right? Since they have a local internet, so can we direct route the traffic, go to the Google, not Google, go to Microsoft. Don't come back to the headquarters. We just send it to the local internet. So that is mean we telling this remote all workstation, go out to the Microsoft, is using your local internet. Instead, the traffic route back to the headquarters, and then from headquarters go back to the Verizon. So far, so good in this concept.
Mm-hmm.
Yeah. Okay. So now how we perform it, right? So for example, in here, right? So that is mean we need to inject something, right? We need to inject something. So for example, for this solution in here, right? So now we go to the let me see, we go to the MPLS router here, right? For example, so we go back to the MPLS router here. You see, this is MPLS router, right? So when we show, you see in here, when we show the IP route, where we go, the IP route. All right. No. You see the IP route is a via by the BGP. You see, by the BGP via. Okay. So now we're going to be inject, right? So it's just temporary in here. See, because we're going to say IP route, we want to go to 4.2.2. Just using the static route for this time, just easy enough, you see. Okay, so it's IP route 4.4.2.2, blah blah blah, and then we have to go to the next hop. The next hop, it should be this IP, right? We point it to the local internet. So what is the local internet IP? Let's hop into this router. All right, so show IP interface brief. Okay, it should be here. This is the next hop IP. So now we go back to here again. All right, to finish it our static route, you see here. So IP route, go to Microsoft update server 4.4.2.2 We're going to be it's like a force the traffic, like a switch the traffic, using static route. On to the next hop, right? Hit enter. Okay. The reason the static route, because you have to understand, right? Because the BGP, you see the AD number is a 20. And static route is 1. Who's the AD? Who is the AD? Okay, we call administration. No, I mean admin something. Okay, I cannot say it. No, the admin. Okay, the administrative distance, something like that. I see. Sorry, been for a while, you know. I just only know the shortcut. It's called AD. Okay, the AD, if smaller, if the like lower, is the prefer on the routing, right? See when here when you show IP route again in here, you see show IP route. So now we have a static, right? You see here, because this one is a default route, because this is like before we inject a static route, everything it should be go to this headquarter. So now where is our static route? Yeah, here. See, now we have a static route. You see, now we have a static route. You see, it's 1.1. Okay, so the estimate is take over. So that estimate is should become to here. Then now we can test it again from the here now. Okay, so now we say we ping again in here. Ping 192. No, not 192. Ping 4.4.2.2. All right, make sure we able to ping from here. Oh, okay. All right, so now we have to go back to here now. Why we cannot able to ping? How about we can ping from, can we ping from here? Ping 4.4.2.2. Mm-hmm. Oh. All right, you see, okay. So still have a problem. Then we go to internet router then. So we go to Chicago internet router, this router here. We ask the router first, just verify from this router. Show IP route. So we want to learn first what this internet router learn IP route for the default route. Okay, so everything the default route, yeah, it should be go to the 68. This one here, go to Comcast, and then Comcast go to here, right? So how about if I ping from here, 4.4.2.2? Ooh, ooh. You see? Do you think this is the NAT issue, right? Because let's see here. See, let's show IP interface brief first, right? Show run in here. Our public interface is F0/0. Yeah, yep. See, we have 68, and then we have IPNet outside, and also we have this is the crypto map. Okay. So now, just for example here, do we have access list in here? Because for the NAT. Oh, this is 101. Oh, so we didn't create yet. So I believe from the private interface the ping it should be no problem because this router, the Google router or Microsoft router, they should be able to know the 68, right? So we should be able to ping, just say ping back to .2 using the source for this router source. It should be able to ping. Just to verify first. Oh, it's not. Why? Right? So why we cannot ping? All right, let's talk to the Comcast now. How about the Comcast here? So let's go back to the Comcast. So what is the Comcast here? Okay, show IPBGP first. Is Comcast is learning 4.4? Yeah, and it should be no problem. 4.2, 4.4.2.2. Yeah, you see. So think about here. So Comcast is no issue ping 4.4.4, but we have a problem in here. But this default route, because but for the internet from this router, we send everything to the Comcast, and then from the Comcast should be able to ping, right? It should be from the 68.1.2, right? Because from the Google router, it should be able to ping the public, the IP. You see here, ping 68.81.2 something here, .2 something, right? Let's go back to the internet router first in here. Show IP interface brief. That one should be 2.2. Let's go back to the here. So let's see from this router, from the Google router, can we ping the Chicago, the internet, the public internet IP, okay, that router. Oh, no return traffic. You see, that is the problem. Really? Okay, let me see. Show IPBGP. Same thing again. Do we advertise? Who advertised this one? Yeah, this is the content advertised. Right? From the next hop from 268.201. Why we have a 201? Why we have a 201? This is funny. Who this router here? 68.81.201. Do you? Oh, here. This is 201. Yeah. Okay. So this is a 201 from the content is okay. Yeah. So let me see here. Same thing. Let me see here. Show IP interface again. Brief. Can we ping by this IP? So ping 68.81.201. No. Hold on. 81. Let's go back to here. What is the IP again in here? Show brief. This one here. Okay. So now go back to here again. No, go to here first. Let's say if I want to ping the remote, the Chicago internet router, I'm going to say using the source with this one. Ooh, this is interesting. How about trace route? You see, this is funny. What's going on? See, in our lab here, or in the real production, can we trace route again? This here. Oh yeah, this is go to 8.0. That's good. You see, I mean, go to here, and then how about the concast? If the concast, let's go back to the concast again. So this concast here, show IP interface. Okay, so can I ping the 68.2.2, right? Because the other side here, see, 2.2. Uh-oh. Why? See, how about that one? That one is ping itself just good, and then he cannot ping .2.2. So let's go back to the this router again. Okay. Oh, what can here? And encryption. Oh, let me see, because we don't want to get encrypted that, right? Because everything the traffic for here, we don't want to encrypt it. That's, well, let me see again. What is the access list in here? Show access list. First thing in here, so we verify again, right? So we're gonna show IP interface free because it's something complaining in here. So go to here, and then we're going to show run f0/0. All right. So this is the show run interface f0/0. You see? Now we have a net outside. That's fine first. We leave it alone. But here we have because we have a crypto map applied to this for the VPN side to side, right? And then what we learn here, show access list in here. So the access list in here, oh, you see? Okay, so that is mean we still need to deny any IP because we don't want to encrypt it, right? We don't want to get encrypted. Okay, let's do like this quick here. Go to config key first. We're going to say IP access list, and then we want to extend 101, right? Now we want to inject say 5. If we want to say 5, and then we want to deny because we don't want to get encrypted for this IP. So deny IP should be the host, the AD1, this one. So we want to say, hey, everything from this IP, right? You see here, 5 deny IP host here, so to any. Okay, so that is mean this traffic you see here. So this traffic to any. Okay, so this entry here, we're going to insert 5 deny IP 6081.2.2 to any. That is mean from this IP we don't want to get encrypted. Okay, so that is the explain. So now show access list again in here. All right, so now you see here. So now we have number 5. You see, we want to deny IP host from one here. All right, so now we try it again now. So if we ping 4.4.2.2 using the source with this one, so hopefully this time is working now. Okay, hit enter. Beautiful. Look at that. Got it?
Mm-hmm.
Yeah. What I did here just to deny, so that is mean from this IP, so here, see, from this IP go out to the internet, make sure it's not get encrypted. It's dropped, you know what I mean? Because we only encrypt whatever the permit. Got it? So now, you see, now we're able to ping now. You see? Now let's go back to the here again. Okay, so now can we ping now? This time in here. So no, before we go to here, let's from the MPLS router first in here. Can we ping from here? Right? No. Because the reason why no, because we have a net entry now. So now we need to take care of the net, right? Because we don't have to apply for the overload, you know, the high net. All right, let's go back to here again. Chicago router. See here? All right. So show IP interface in here. You see here? So this here is telling everything go out to the internet is the local internet, right? Everything go out this internet. So show run in here. Interface F0/0 again here. You see? So we want to, yes, let's see here. Show run. Do we have a net IP here? Section IP net. Do we have net entry? See, we don't have a net entry yet. Okay, so now we try it now. So now this is refresh again. So make sure we should be okay from here, right? So let's see. So complete key. We're going to say IP net. We want to say source. No, IP net inside, right? Everything inside. IP net net inside. So then we have to say our source address. All right. Now we have to be using the list, right? So for example, if we're using the access list here, so we say 10 access list 10, right? And then we go to the interface because we want to overload. Remember, we have to overload to one IP. So interface in here, let me see, do we have overload? Oh no, we have to get, we're going to tell the interface first. What is the interface here? So that is interface, it should be this interface. Right, so now we're going to say this interface. Now we're going to overload, you see? All right, so now do show run again section IP net, see? So now we have a net entry, you see? IP net inside, see here inside, everything the traffic inside here, we're going to match the access list, and then we're going to the access interface. So we're going to be overload with that 6881.2.2, that IP. So everything, the private IP address in here, when leaving this router, is going to be IPNet translated to the private interface, the single IP interface. It should be 6881.2.2. Okay, so now we're going to create the access list now, right? Because we have to be matched. So access list, we have 10. We're going to say permit. Permit. Let's see. This is 10.205, right? We want to be just quick demo in here. Just say maybe say any. Let's see if we want to. I don't want to say any in here. How about say 10 network? Just say 10 network. 205. Okay, because everything in here is 205. Let's see what else. 205. Okay, then we want to use the wildcard, right? Because we say we want to use 16. 16 should be a lot, right? It's covered everything from for 10.205. Let's do that. So we're going to say 0.255.255. Okay. So that it should be covered for 16 slash. Yeah, it should work. Let's try it then. Okay, so now exit out again. We show again in here. Show access list first in here. Okay, so now we have show access list here. This 10 in here, right? So now let's try it again in here. Can we ping 10 dot, no, not 10 dot, 4.4.2.2. We're going to say, oh, beautiful. Look at that, look at that. It's working. So now let's go back to here now. Quick. Show IPNet translated. You see? Beautiful. You see? So now when we go to the trace route again in here, right? We trace route again in here. Trace route is a 4.4.2.2. You see? Now this time it should be go directly local internet instead coming back to the MPLS. No, instead coming back to the tunnel, to the headquarter like this. It should be now. It should be directly go to here. All right. So just to verify, you see here. Okay. Hurry up. Hurry up. Oh, yep. You see 168, and then it should be going out 68, 81. Yep. And then go to the Concast, and then go to 4.4.2.2. Beautiful. So now, in this case, so we resolve now the internal for our users from different, especially in here from the headquarters. Say now we have a solution now because now we reroute the traffic for Chicago, go out to the Microsoft 4.4.2.2, the Windows patch server, and then they go to locally. Now is reduce the traffic now instead going to here. So now in this side, go out to the internet. Is more efficiency, is more happy. Okay, so far so